Example 5.3b will be very similar to 5.3a. I'm still providing you with f and g, but I'm doing so with unspecified domains, which means I'm giving you the equation only for f and g, but we're wanting to do the same thing in terms of finding f plus g, and then also we want to be able to state the domain of f plus g. So same two things as we did in part A. Let's start with the equation. We're going to take f of x and we're going to need to add g of x. So in order for this to happen, we have to recognize that we are going to be taking two fractions and adding them together. Now the only way for me to be able to add two fractions together is if they have a common denominator. Now it is certainly easy for me to see here that one of the denominators is going to subtract 2 from whatever number we pick. The other denominator is going to add 3 to the same number that we would be picking to play with. So there's no way that these denominators are going to be the same. So what we'll need to do is multiply by a creative 1. We'll multiply top and bottom by x plus 3 for the first fraction, multiply top and bottom by x minus 2 for the second fraction. And what this will do for us, in the first fraction, I'm going to distribute 8x to the x and the 3. So I would have 8x squared plus 24x. And then in the denominator, I'm going to leave my multiplication in factored form. So I'm not going to actually distribute it out. Just leave it as x minus 2 times x plus 3. And then the second fraction, I'll do the same thing. I'll take 6 and I'll distribute it to the x minus 2 in the numerator, and that will give me 6x minus 12. And then denominator, I'll write as x minus 2 times x plus 3. And this makes it really easy for me to see that I have a common denominator now. So all I have to do is perform the combining of like terms with the numerators. So the numerators will combine to give me 8x squared plus 30x minus 12, all divided by x minus 2 times x plus 3. And once you've combined them together, now we're dealing with a quotient looking expression. Now we didn't create the quotient. The quotient was already part of the function f and g because they were already fractions. But it doesn't hurt to maybe check to see if there's some kind of extra factoring that can go on. So at this point, there's not really a lot of factoring to be done in the numerator. The denominator is already factored because we didn't multiply it out. So that was the reason why we didn't do anything with that. We wanted to leave it in factored form. But for the numerator, we can do a GCF of 2. So we'd have 2 times 4x squared plus 15x minus 6. And I don't believe that we can do anything else with that. You can try to do maybe some trinomial factoring, but ultimately you're looking for something to match x minus 2 and x plus 3, and we're not going to get any cancellation there. So this is a good place to stop with the f of x plus g of x. Now moving on to the domain conversation. So for the domain, we know that we have to be looking for the domain of f, we need the domain of g, and then the domain of f plus g will be the intersection of the domain of f with the domain of g. So let's talk about the domain of f. And we were mentioning that f and g are both fractions, which means they have a divide by in them. So there we have x minus 2, and analyzing x minus 2 would mean that x is not supposed to be 2. X is not allowed to be 2. And if I do the same thing with the x plus 3, that would tell me that x is not allowed to be negative 3. So the domain for f will be negative infinity to 2, union 2 to infinity, and the domain for g, negative infinity to negative 3, union negative 3 to infinity. But I want to be able to intersect these two ideas together, So let's graph them on the number line. We'll call that 0. Over here is -3. About right here would be +2. Let's try that again, +2. So the domain of f will be open at 2, but then everything to the right and left will keep. The domain of g will be open at -3, and then everything to the right and then to the left of that. So remember, when we talk about intersection, we're looking for the overlap of these two intervals. Now sometimes it's easier to think about where they don't have overlap, and that sometimes is a smaller list. And in this case, if you think about it like that, you'll notice that there's two values that they don't both have. -3 is not a part of both of them. It's only a part of one of these intervals, and then +2 is also a part of only one of them. But everything in between -3 and 2, there's overlap. Everything to the right of 2, there's overlap. And everything to the left of -3, there is also overlap. So this would lead me to say that the domain for f plus g, that's the new function that we're creating, will be -∞ to -3, union -3 to 2, union 2 to infinity. Now the only thing we have left to do is write our function definition. I am going to box this domain in that we just came up with. That's the stating of the domain of f plus g. So now let's do the definition for f plus g. Let me copy down the domain again. And that's the domain that maps to all real numbers, or maps to real numbers. We don't necessarily have to use them all. Given by f plus g of x is equal to 2 times 4x squared plus 15x minus 6, all divided by x minus 2 times x plus 3. And that gives us our full function definition. It has the equation along with the appropriate domain.